A finger traces the thick arrow on a classroom world map, leaving Africa and fanning out like the answer is obvious. Ancient humans did not travel the world in one clean journey. That arrow is a shortcut, and it hides the real story. Because if you press on it, it breaks. The neat line cracks into thousands of tiny footprints. They cling to rivers where fresh water is predictable. They hesitate at deserts where a dry season can kill you. Some stop for generations in good valleys. Others vanish under ocean water, because the shorelines they used during the Ice Age are now drowned. So if ancient humans spread everywhere, why do the usual map arrows feel too neat to be true? Because the global spread was built from countless small survival moves. Not one planned continent-hopping route, but many starts, pauses, and detours made by different groups across deep time. And ancient humans doesn't mean just Homo sapiens. Earlier Homo groups left Africa long before our species' main expansion. Much later, Homo sapiens moved into regions that already had people like Neanderthals and Denisovans. Eurasia wasn't an empty stage waiting for us. Archaeology and ancient DNA show overlap, contact, and mixing. This is what changes the picture. Each footprint is a short decision. Find the next waterhole. Follow the herd one ridge over. Move when the habitat math stops working. You can still see that instinct today, in wildlife during droughts, and in human communities when harsh winters or failed rains force hard choices. So if there wasn't one big trip, what did migration actually look like on the ground day to day, family to family? Ash is still warm when the wind shifts, the water nearby has dropped, and the plants are brittle. A family packs what they can carry, lifts a child, and walks for 2 days toward a greener valley they've visited before. That doesn't feel like world travel. It feels like a normal decision. Move when the campsite stops working. So how can tiny movements just a few days' walk turn into humans reaching the far edges of the world? Because long-distance human migration was usually not one epic trip. It was relocation, repeated. People worked in seasonal territories, looping between known water, game, plants, and shelter. When rain patterns changed or a herd shifted its route, the loop stretched. When a group grew too large, it could split, with a few families trying the next valley over. Now imagine the same choice. Again, their grandchildren face another dry spell, another crowded river bend, another worn-out patch of shoreline. They also walk 2 days, not into the unknown, but into the next workable place. Do that across thousands of generations, with long pauses where life is good and populations stabilize, and those short steps link up. The journey becomes a chain made from ordinary moves. Archaeology fits this. Campsites often have stacked occupation layers. People return, leave, and return again. Toolstone and raw materials show shifting sources, as groups range farther or connect to neighbors. This is how wolves expand, how elephants push into new range, how seabirds colonize new coasts. Nobody aims for a continent. Each generation follows the next reliable patch of food and safety. If local survival is the engine, what were ancient humans actually following most coastlines, rivers, animals, or something else? A hand presses a wooden stamp into damp sand, trying to pin one clean date onto human history. But the sand won't hold it. The edges crumble, and the mark smears wider and wider. That's the problem with the phrase, out of Africa. People talk like it was one departure, one time, one group. But ancient humans were not one species moving in one wave. So when did Homo sapiens actually leave Africa, and why is the date always argued about? Because the question is really 2 different stories stacked on top of each other. Long before Homo sapiens spread across the world, earlier Homo groups had already dispersed out of Africa. Those movements are part of how Neanderthals and Denisovans end up in Eurasia, and they happen on a much deeper timeline. Then, later, Homo sapiens expands. And even here, it's not one exit door. Many models put the main ancestry-forming expansion somewhere in a rough 70,000 to 50,000 year window. Not a single year, a window. There may have been earlier Homo sapiens movements beyond Africa before that. Fossils and archaeology hint at possibilities. But those earlier attempts might have been small, short-lived, absorbed into other populations, replaced later, or simply left little genetic ancestry in most living non-Africans. That's why researchers separate earlier dispersals from the main ancestry-forming expansion. One leaves a loud genetic signal across many populations today. The others can be faint, local, or missing. It's like tracking an animal reintroduction. A sighting doesn't mean a successful colonization. What matters is persistence, repeated generations, and connections that don't die out. So don't ask for one out of Africa date. Ask which movement you mean, and what kind of evidence you're using. Okay, once groups were moving, what made some routes workable at certain times and impossible at others? Wet sand squishes under bare feet as people fan out along the tide line. Someone pries a shellfish loose. Another points at a cluster of birds diving for fish, and a child learns the simple rule: where the water meets the land, food keeps showing up. So, did ancient humans mostly travel by hugging coasts, or by cutting inland? The honest answer is both. Coastlines are natural highways. You can keep the ocean on one side and you won't get lost as easily. And the edge where land and sea meet can be packed with calories. Shellfish, fish, seabirds, seaweed, stranded animals, and fresh water where streams hit the shore. But coastlines come with a twist. During the Ice Age, sea level was often much lower, exposing wide coastal plains and sometimes shortening distances. Later, as seas rose again, many of those old shorelines went underwater. That means a coastal route could have been important for human migration, while leaving fewer camps that archaeologists can find today. Part of the route argument is really an evidence argument: what survived on land versus what drowned. Now move away from the salt air and follow a river inland. Herd animals converge to drink. Edible plants cluster along the banks. Stone outcrops for tools sit nearby. Camps can pop up again and again along the same corridor, like stops that make sense to everyone who learns the landscape. Which route worked depended on climate windows. A valley can be a green corridor in one period and a dead zone in another. Paleoclimate and sea level reconstructions show these shifts happening again and again. Modern animals still do this. Salmon runs, wildebeest corridors, elephant trails. Ancient humans were reading the same resource maps, just with fire, tools, and shared memory. If walking and natural highways explain most movement, what about places you can't reach by walking, like Australia and New Guinea in the Ice Age? Salt air sticks to skin as a small group stands at the edge of dark water. They can't see a path under their feet anymore. Out on the horizon, land is only a darker strip against the night. If most human migration was walking, how did ancient humans reach Sahul Ice Age, Australia, and New Guinea when there were still water gaps? This is the moment walking stops being enough. Even with Ice Age coastlines pushed farther out, there was no full land bridge from Southeast Asia into Sahul. The distances changed, but the problem didn't vanish. Shorter did not mean optional. It still meant wet. So reaching Sahul required water crossings. Not one heroic ocean voyage, necessarily. More likely a chain of crossings, island to island, repeated short trips, and the kind of choices that only work with cooperation. Someone has to carry tools, food, and fire. Someone has to keep children safe. People have to wait for calm water, read currents, and move when weather gives them a window. The craft could have been a raft, bundled logs, lashed bamboo, or something just as simple. We almost never find the earliest boats because wood, fiber, and reeds decay. But geography forces the conclusion that some kind of watercraft, however modest, was part of the migration toolkit. And there's an anchor on the far side. At Majid Bebe in northern Australia, archaeology is widely discussed as showing people were already there by about 65,000 years ago. The details are debated, but the implication is hard to dodge. Humans crossed water to arrive. Plenty of animals reach islands by accident. Humans can do it on purpose, together, with shared timing and shared knowledge. So how do we know any of this: routes, contacts, crossings, when so much is lost to time and water? Boots crunch over frozen ground where there shouldn't be land at all. To the north and south, ice sits like a wall. But here, between Siberia and Alaska, there is a huge belt of dry, cold country. That place is Beringia. And the old school story makes it sound like a narrow bridge you cross in a week. It wasn't. It was a wide tundra steppe with rivers, windswept plains, camps, and big animals moving through. So how did ancient humans reach the Americas? And why isn't it as simple as cross the land bridge, then walk south? Because the hardest part wasn't arriving in Beringia. The hardest part was leaving it. For long stretches of the Ice Age, the route into the rest of the Americas was blocked by massive ice sheets. On a map, you can draw an inland passage. In real life, that passage only works if it has plants, game, fresh water, wood, and places you can survive while traveling. Here's the correction. A geographic corridor is useless if it isn't an ecological corridor. Dry land alone doesn't feed you. Now imagine two doors out of Beringia. One door is inland, squeezed between ice, opening and closing as climate shifts. The other door hugs the coast, where sea ice, storms, and narrow beaches make travel dangerous, but where marine food could help you keep moving. That's why the route debate is still alive. Some evidence fits an earlier coastal pathway. Other evidence supports later inland movement once the interior became livable. Either way, the story is about timing and habitat, not one clean arrow. It's the same logic conservationists use today. They don't just ask if animals can cross land, they ask if the land can keep them alive. With drowned coastlines, shifting ice, and almost no surviving boats, how can scientists reconstruct these journeys at all? A lab tech clicks a sequence into a computer, and a string of letters becomes a family tree. One branch splits, another reconnects. That's ancient DNA, turning old bones into relationships. But if ancient humans left no maps, how do we rebuild their routes, and why will the story always stay a little messy? We rebuild it by stacking different kinds of clues that don't depend on each other. Archaeology tells you where people lived and what they used. Stone tools, hearths, butchered bone, the leftovers of daily life. Fossils put bodies in specific places and times. Paleoclimate and sea level history tell you when a route could actually work, when deserts grew, when ice blocked valleys, and when lower seas exposed land. Then genetics adds something totally different. Ancient DNA can show branching histories and mixing, including contacts with Neanderthals and Denisovans. It can tell you that two groups met, or that one population contributed ancestry to another. But it can't tell you the exact shoreline someone walked, or whether a water crossing used a raft, driftwood, or something we'll never find. Here's the part people miss. Some evidence is gone for real reasons. Ice Age coastlines are now underwater, so whole chapters of migration could be drowned and erased. Put the layers together, and the picture sharpens. Take one layer away, and certainty fades. The best model isn't one bold arrow. It's a changing network. Local moves, shared knowledge, seasonal timing, and social ties, repeated for generations until the world fills in. We still travel that way today, using weather, roads, and messages from other people. They used rivers, seasons, animal movement, and stories. When you see that single bold migration arrow again, what should you picture instead? If you like this video, don't forget to like, share, and subscribe to stay tuned for future videos.